Hello everyone. Welcome to another video of Cloud World. My name is Santiago. So on today's video, we are moving away a little bit from the Azure side. We are not going to be talking too much about the cloud because this intermediary video is actually going to be very important in order to understand what we are going to be doing after. So what we are going to be talking today. So we will going to talk about Docker. We will talk about Podman, which is likely the same thing. We could call it that way. We are all going to talk about Kubernetes. We are going to explore what Kubernetes is, and after that, we will be doing an example in the local environment on how to deploy an application using Docker and also the Kubernetes tooling. So let's get started. So let's start talking about what Kubernetes is and what is Docker. So at this point, I will expect you to have a little bit of experience at least with Docker or Podman or similar tools. But in a big context, on a very short context, we could call it more better that way. We will have that Docker is a container management tool, which is going to allow you to operate anything related to containers. You will be able to build images. That means you are going to be creating definitions for containers, and also you will be able to deploy those images into another infrastructure, also being supported by the Docker tooling. You will be able to manage mostly everything related to containers, like as an example, networking, volumes, relationships and connection between containers, and so on. So Docker in a very specific way is going to provide us the tooling for creating images that are going to be used to deploy containers. So here it comes into place Kubernetes, one of the most fantastic tools that have been created in the last few years. So the initial parts of Kubernetes come from the Google time. They created an initial version of Kubernetes. There was an internal tooling, and after that they make a public version available. And today this project has been evolving a lot, which is already being supported by the Cloud Native initiative. And Kubernetes is actually open to be used by anyone, and is actually available in several cloud providers. Of course, Azure is one of those. And if you missed one of the previous videos, we already created a AKS cluster or Azure Kubernetes cluster already. So dial back into that video. I will leave you the link into the description in case you want to follow up. But also we can have Kubernetes in several places. So let's dial a little bit on this point. When you are executing Kubernetes, you are not tied to the cloud. For example, you can be running Kubernetes into the cloud using virtual machines, because at the end, Kubernetes is going to be using some kind of compute in order to operate properly. So in the Azure side, in the Amazon Web Services side, and the Google Provider Cloud, and many other services, or even on-premises service managed by a company by itself, you can execute Kubernetes, and Kubernetes is going to be running on that hardware that you own, or maybe a virtual machine if this in the cloud, in the case of the cloud, or maybe a already prepared environment on premises with virtual machines. But that doesn't set the limit. You can execute Kubernetes in your own laptop, your desktop computer, and also Kubernetes is, let's say, so like and open to be used that you can execute your own version of Kubernetes in devices like Raspberry Pi or similar. So this is an example how flexible Kubernetes is. Now, taking into consideration that Kubernetes can be executed mostly everywhere, since you have the proper hardware to execute Kubernetes is going to set up something that is known as the control plane. So take a look into the screen. So we have the control plane, which is going to be like the main operator of everything that happens into the Kubernetes. The control plane is composed of several APIs and several internal services that allow the operation. I am not going to deep dive, at least not for today, into those concepts, but I will dial back into very important topics and concepts that we need to take into account. So when you deploy an application into Kubernetes, you are building something that is a deployment. The deployment is going to be a configuration that is going to fit itself with a image or a container image. Like I said, it could be Docker or Podman or something similar that build that image. It doesn't matter too much. So Kubernetes is going to create a deployment. That deployment is going to be composed of what we are interested to do with that application. I'm going to give you an example. So you can say how many pods you are going to be executing. So what is a pod? A pod is a unit that could be composed of one or multiple containers, and each one of these pods is going to execute an exactly replica of your application. Let's suppose that you are running today a web API. If you decide to go with 4 replicas, it means that when the deployment is ready, 4 different pods will be ready to take the requests that go to that API. So it doesn't matter where the requests go, one of the pods is going to be taking that request. So that means these applications are stateless because they should provide the same solution altogether individually. So that is important to keep in mind. But when you define the deployment and you set up how many pods you would like to use, internally Kubernetes is going to be creating something that is a replica set, and the replica set is going to be that part of the Kubernetes cluster, that component or definition that is going to take care of the health of your pods. So if you request or define a deployment that is going to need 4 pods, the replica set is going to be the part of the control plane that is going to be responsible to make sure that the deployment get those four replicas. If at any moment maybe one of the pods crashes or something unexpected happens, the replica set it is smart enough to replace that pod with a new one. So the deployment, what it actually does, in a context of bigger definition, the deployment is going to consume the pods that match something that we define in the criteria of the YAML file. We will see that in a minute. So now let's start exploring a little bit about the Kubernetes definition. So when we speak about any object that you would like to deploy into a Kubernetes site, you need to express that part of the component in either a YAML way or a JSON way. The YAML way is actually the most popular around, so it's very common to see it because it's actually easier to read and is more or less a standard in the industry already. So let's explore what is a deployment. Something when we are creating a Kubernetes definition, we have to define an API version, and we have to define the kind of object that we would like to deploy. In the kind, we can have things like a deployment, a service, something that we are going to be exploring in the deployment on Azure in later videos. And also we can create individual pods because Kubernetes is going to give us the capability to even create individual pods. You can define replica sets manually. You don't have to, because when you create a deployment, the replica set is created automatically on the back, and you can create, for example, volumes, which is a reference to persistent storage, like let's call it a hard drive or something similar. And many other things. You have cron jobs and many other definitions. For today, we are working with a deployment. If you remember, I mentioned previously when the deployment is going to be taking advantage of tagging of a metadata that the pod defines. So here in the deployment, we define 2 very important things. First, we gave our deployment a metadata which is going to allow superior resources to find this deployment easily. When we deploy a service in the Azure side in later videos, we will use very similar tags in order to find the deployment. So following the same logic, when you build a deployment, you need to specify a couple of things inside the configuration. So this piece in here belongs to the configuration of each one of the pods that are going to be part of this deployment. So we have how many replicas we would like to have. So this is like in a short term, how many pods we would like to have in real time. So this could be 1, 2, 3, 4, and so on. That will be tied to the resources that you have available, and maybe other, let's say, more sophisticated configuration like resource quota and similar. But the most important part in here is that for each one of these pods that you create, you need to give a label. In this case, the label is going to be the app tag, and we are giving it the name CloudWorld Console App. So when the deployment gets created, the replica set is going to create also all the pods with all these tags and labels that we have defined in this section in here and in here as well. And what the deployment is going to do is he's going to look up for all the pods that match this particular label. So as you can see, we also have the labels and the definitions in here as part of the container definition. So this part in here belongs to the pod definition, and this internal part is actually how we are going to define the container that run inside our pod. So like I mentioned previously, a pod could contain many containers internally. That's a pattern that is usually saw in some application, like having a sidecar or a pod that is doing something additional to the main pod. For today, we are only executing a single container inside our pod, but just be aware that you can have multiple containers inside of a single pod. So using this information, the containers will be created with these tags, and all the containers that match this tag are going to be selected in here by the deployment. So since we have multiple replica sets that are going to be created with this metadata defining here, he's going to find how many pods do we create. In this spec part, we define how the containers are going to be created. So here it comes the important part. We give a standard name to the name of the containers. We also provide which image we would like to use in order to build our pods. In this case, the container definition, we are going to be using this image we are going to be building in a few moments using Docker. And we have the image pool policy. This is when we should retrieve the image. In here we have additional configurations, like for example ports. We are not using this one today, just I wanted to give you an example in here because we can expose ports in the containers, and those ports could be tagged later into the deployment and a service, which is a superior layer, in order to expose, for example, the deployment through HTTP and using the service in order to access applications like web APIs or web applications. And the restart policy is what happens when a pod dies. So in case the pod crashes or have a malfunction or something it goes as unexpected, the replica set is going to restart the pod, and if there are like continuous failures, the replica set is going to replace that pod. Now that we have our basic YAML configuration, like explaining here, we need to provide a container image in order to deploy it into the Kubernetes cluster. So this is part of the deployment. So in here we have a very basic .NET application, console application, which is going to just execute very simple, and is going to log some information into the console. Very simple. It is nothing too fancy in here. What I would like us to explore in here is going to be this Docker image, which is going to contain the information for the application. So the Docker image is going to build the console application that I just showed you in here. It uses a multi-stage build in order to get the SDK runtime, the SDK and the runtime as well, in order to execute the application and also to build the application. So the SDK is used to build the application, so that means to compile our code and package that into a meaningful deployment. So after that, the runtime is going to take that code and is going to execute it into the container. So this is what our image is going to do. It is going to build our application and it's going to create an image from it. So every time that we run a container using that image, is going to execute the console application with a very basic code that I just showed you a moment ago. So now I need to build this image. So I will go to the terminal in here, and I'm going to use the Docker build. In this case, in case you are using, for example, Podman, just replace the word Docker with Podman just to build your image. Or if you are using other container tool, just replace it with the proper name. In this case, I just suggest to use Docker if you're not a company. If you are a developer, you can have free access to it, and you can use it for experimenting, to store in your local environment, and they allow you to do that as long as you're not a company and you are not using Kubernetes Docker for real world scenarios. So the Docker build is going to ask us to provide a Docker file of code, which is the one that we just explored a moment ago. And we need to use the tag, which is the -t, a parameter, in order to give it a name to the image. If you don't provide the tag naming, is going to provide a random name, which is not going to be very meaningful in the real world. So let's execute this. This is going to compile our image in here. This might take a few seconds, depending if he has to pull several images and stuff like that. This might take a little bit more. So if I use the Docker image ls, this is going to list all the images that are available in my machine. So as you can see, we have a couple from Kubernetes that are used to execute the cluster locally. But the one that I am interested with is to have this one as part of the local registry. So our image is ready to go. So now what we need to do is to use tooling in order to interact with a Kubernetes cluster. The easiest one to use is the kubectl tooling, which I'm going to drop you a link into the description as well, and you can also install this tool pretty easily in your local environment without any major configurations. If you choose to use Docker Desktop as your solution, Docker Desktop is going to include everything that you need to. Of course, Docker for building the images is going to also to contain a Kubernetes cluster that you can enable and have everything running locally, and it's also going to provide to you the kubectl tooling. So the kubectl tooling, it is going to allow us to interact with the Kubernetes cluster. So the kubectl just hides a couple of API requests that happen into the backend. So every communication you do to the Kubernetes cluster happen via an API, which is not visible for you, but in the backend of the kubectl, it's just making a HTTP request to your Kubernetes cluster. In this case, we will use the kubectl tooling, like I said, and we are going to be using the apply operation in order to apply the changes. We need to use the -f and provide a file with the deployment, or the file, or the service, or the ingress layer, or the replica set, or whatever we would like to deploy in the YAML format in this case. So just by providing the file name, we can execute enter, and as you can see, we will get the deployment apps, CloudWork console app has been created. So everything looks good so far. So let's use the kubectl once more and use the operation get pods, which is going to list all the pods that are available in the default namespace. So as you can see, since we requested 4 replicas, we have 4 pods that are CloudWork console app and a random naming here that are actually running. If I like to explore a little bit, I could use the get rc, which is actually replica set, and I can take a look into the tooling. So as you can see, we have the replica set, and it says that we decide to have 4 pods. 4 are available and 4 are ready to use. So as you can see, it's going to give you a follow-up on the pods that you have. So let's go back into the get pods. And if I try to explore one of these pods to see what is happening inside of them using the log system, now with the kubectl logs, we can provide the name of the pod and access the logs that have been written into the pods. So if we take a look, we are getting some output information from the usual deployments from Microsoft. This is some basic information, but the important part is that we are getting the hello world cloud in here, which is the basic information that I use from the logger just to display you this example. If we make any changes to the deployment, let's say I just want to reduce this to only be 2 replicas instead of 4, I can then again use the apply command to apply the deployment. The Kubernetes cluster is actually detects the drifts or the changes that happen since the existing deployment and the new changes that you are applying, and it's going to apply those. In this case, the only change that we have is the amount of replicas. So if once more I use the get pods, I will see that we only have 2 pods. And if the same level, if I then again explore the replica set, we see that we have 2 desired, we have 2 currently running, and 2 of those are ready to be used. And once more, I could use the kubectl logs in order to check one of the new pods and take a look into the output. Then again, we have the cloud operation in here. So in today's video, we explored a little bit what is Docker, some of the basic things about Kubernetes. We created a very basic Docker image using a .NET application, and after that we created a deployment in Kubernetes. On the next video, we will be exploring something that is the Azure Container Registry, which is going to allow us to push images into the Azure side, and we will be using those images in order to deploy those into the Kubernetes cluster. So I hope you learned a lot from this video, and see you in the next one.